Oh, good evening, everybody. My name is Ravi, and I'm your master teacher. Well, welcome to Diksha Karnataka, and where we bring a lot of videos for you. So stay tuned. Well, this is my second lecture about magnetic effects of current. I hope everybody is preparing really well. Good evening, everybody, once again, those who are joining, and keep on commenting. That really pumps me up. Well, thank you very much for joining again. And this is the second lecture of magnetic effects of current. The first one, if you have not seen, please go and watch. There I covered every single topic in depth, which will be really helpful for all those people who have not done this chapter before. See, this chapter is now, it used to be 2 marks, 3 marks 5 years back. Last year onwards, the weightage of this chapter has gone from 5 marks, 7 marks, 8 marks, something like that. So you can expect about 5 to 8 marks from this particular chapter. The chapter is very small, is easier. There's not many numerical values involved, just the direction involved. So if you just understand few things in this chapter, you can really make it. So guys, in this particular lecture, what I would be doing is, I would be eyeing on, we'll just quickly go for a recap of what we have done so far in our last lecture. Followed by, I will explain about what kind of questions are asked in exam. We'll be discussing few things, few lectures, few theories about it. And then followed by, we'll be doing some PYQs, previous year problems, as well as we'll be discussing some really important questions and the format of the exam. So stay tuned with this, stay tuned with me, and let's go further. Yep. So magnetic effect of current, lecture 2. First one, please refer to our channel. Over there you can see our first lecture where I covered every topic in depth. So let's go and start with this. All right. Okay. So, all right. So here we go. So let's take a quick recap, guys. Quick recap. Okay. This is a particular thing which comes in exam. And last, okay, from this chapter itself, there are few things are very important. If you take 5 years, 10 years of paper, you will see the examiner have focused on right hand thumb rule, Fleming left hand rule, solenoid, and domestic circuit. So these 4 topics examiner has actually kept an eye on. So you please understand this topic, these 4 topics pretty well, and I'll be explaining you in this video. In this recap, I'll be explaining you again, but to have a good in-depth knowledge about the same, please go ahead and check the previous video of mine, which was recorded few days back. You can have a look over there, and if you have any doubt, please leave the comment in the comment box and I'll get back to you through the comment box. Thank you very much. So let's go ahead and start our chapter, magnetic field due to current carrying conductor. This is the heading of it. Over there we study there is something called right hand thumb rule. So what is this right hand thumb rule? See guys, this chapter is all about direction of magnetic field. That means they will give you conductor in which the current is passing. The shape of the conductor can be of 3 types. One is your straight line conductor, loop, and third one is your solenoid. You need to study about all 3. If the current is passes in a straight line or in a loop or in solenoid, what kind of magnetic field is produced, what will be the direction of magnetic field, and what sort of magnetic field is produced. So this is what we are going to study over here. Right hand thumb rule gives you that whenever there is a current in a conductor, we use right hand thumb rule to find out the magnetic field directions. How do we do it? Again, just a recap. In my last video, I've explained it pretty well. Just a recap of this. You can have a look. You see the conductor. You see wherever the current is going, keep your thumb over there and curl your finger. Just see. Keep your thumb in the direction of current. Let's say current is going from bottom to top. This will be your magnetic field. You see my fingers is going like this. This will be the magnetic field. And it will be concentric circles. So as we go away from the conductor, the strength of the magnetic field goes down. This is how it works. All right. So this is your right hand thumb rule. Okay, I hope it's pretty much clear. Please leave your comment in the comment box. Yeah, if you have any doubt, yeah, I'm waiting for it. All right, please leave your comment. If you like the video, please like it. All right, so these three kinds of shape are asked in the exam. So one of it will be asked, by the way. All right, and most important shape among them is solenoid. Examiner focuses on this shape. So let's go further. This is the current direction, magnetic field, concentric circles, right hand thumb rule. This is how it gives you. All right. So second part is using the right hand thumb rule. Over there, you see the magnetic field in a straight current. So it means the conductor is straight. It means there is a straight wire. The current can be from bottom to up or from top to bottom. In each case, how the magnetic field direction is going to be, it is mentioned over here. Just have a look. You see the magnetic field. These are the concentric circle. What is the meaning of concentric circle? Which has the same center but different radius. Okay. So as you can see, just keep your right hand over there in the direction of your thumb, in the direction of conductor, in the direction of current, and your finger gives you direction of the magnetic field. If you make it opposite, ulta, you see this way. The magnetic field is going in this direction. I hope it's pretty much clear, right? Similar thing happens in a circular loop. In circular loop, what happens is, if the current is passed through in a circular loop, this is how the magnetic field looks like. So how do you find it? You take the tangent on this loop. Anywhere you want to find the magnetic field, take the tangent on this loop and see what is the direction of current over there on that tangent. I hope everybody can understand me. There is a loop. The direction of current will be like this. Let's say it's going in this direction. So I put a tangent. So on this tangent, the direction of the current will be upside. And just put your right hand thumb. It gives you the direction of magnetic field. At the center, guys, this is where one question, actually MCQ was asked some time back. At the center, over there, at the center, the magnetic field will be from in to out, as you can see. Okay, this is three-dimensional, right? Magnetic field is like this, so there will be a uniform magnetic field at the center. If you go away from center, it just becomes concentric circles, and if you as you go closer to the loop, the strength wise is increases. All right, I hope it's pretty much clear. Let's go further. This is just a recap. If you want to have a further understanding of the topic, please refer my video what we have I have made few days back over there. Please refer that video. You will have a pretty good insight of this particular chapter. This is just a recap, guys. Okay, so let's go to the next part, solenoid. This is a favorite topic of the examiner, favorite topic. It means if you see past 5 to 7 years, every single year the question has been asked on this particular topic. So we'll cover this topic once again, slowly, easily. Okay, let's see. So what does it say? If you see this guy, first thing first, solenoid. What is solenoid? It's a closely packed wire. Closely packed. It means there will be number of turns, keep on turning, it becomes a solenoid. First thing is that. Second thing, what is it? We give current. If it is negative, it must be not. Don't do ulta. Please make sure when you are plotting this thing, if this is negative, it will be, north will be over here. So once you are plotting this solenoid, you're giving negative over here, positive over here, the north should be here. If you want to write north over here, give this negative, this positive. Please make sure, please do not make this mistake, otherwise your marks will be bye-bye, gone. You won't get marks in that. All right, so this is the second part which you have to take care when you are plotting this solenoid. Okay, third thing is, what kind of magnetic field we have in solenoid? Inside the solenoid, as you see, the magnetic field is uniform. And inside the solenoid, magnetic field is from south to north. Outside the solenoid, the magnetic field is from north to south. I hope everybody can relate this with bar magnet. And bar magnet, if you remember, this is north, this is south. So magnetic field is from north to south. North to south. And since it is a closed curve, it is a closed loop. So inside inside this bar magnet, the magnetic field direction will be south to north. I hope it's absolutely clear. For those this thing is not clear, please refer back, go back and watch my first video. There I have covered this thing in quite a depth. All right, so let's go further. What else is over here? Okay, solenoid can be compared with bar magnet. It is very similar to bar magnet, very similar. What is the difference? Main difference is this is an electromagnet, this is a permanent magnet. Bar magnet is a permanent magnet, solenoid is an electromagnet. So we can increase or decrease the magnetic field of solenoid by increasing the current. So if we increase the current, let's say current increase, when I write arrow up, it means is increasing, by the way, those who don't know. Okay, I think all of you know, this is pretty easily understandable, this part. If the current is increasing, the magnetic field will also increase in solenoid. First part, very important from the MCQs point of view. What happens if the current increases? What happens in the magnetic field? So if current increases, the magnetic field also increases. Second thing, what about the number of turns? So if number of turns increases, your magnetic field increases. Okay, these two statements are extremely important, guys. We are spending more time on solenoid. There is a reason behind that, because this has been an important topic in past 5 years. So I hope it's absolutely clear to you. Please do not make this mistake. First one, negative north, positive south. Direction of magnetic field, once you plot the solenoid, it must be inside south to north, outside north to south. Okay. Third, magnetic field inside is strongest. So it means let me take one point there inside. All right, so let me take this point here inside. Let's say this point is A, this point is B, and this point is C, which is outside. So this question was asked in, I think, 2022 board exam, if I'm not wrong. Okay, where they asked about where is the strength maximum, where is the strength minimum. So this was asked. There were 3 points were given. A point is inside this solenoid, B point is at the pole of the solenoid, C point is outside the solenoid, which is above this. So inside the solenoid, the magnetic field is strongest. So A, it will be strongest. C, it will be minimum, the weakest. And B is actually half of A. So just at the end of the solenoid, the magnetic field strength is half of what is inside. All right. So, but you just have to remember which one is maximum, which one is minimum for the board point of view, and is done. So again, the difference between, okay, this question was actually asked, what is the difference between solenoid and bar magnet? This was a previous year board problem. So what is the difference? Solenoid is an electromagnet. This is a fundamental. So being electromagnet, its magnetic field can be increased, can be decreased, and we can even change the poles. We can bring south to north, not north in place of south. All we have to do, connect this with the negative of the battery, this with the positive of the battery, the polarity changes, the pole changes, which is not possible in bar magnet. Okay, but solenoid acts as a bar magnet. All right, so I hope this is absolutely clear, guys. Let's go further. So this is actually supposed to be a recap, but I'm spending more time on more important topics. All right, so let's go further. Next topic. Okay, so next one is Fleming's left hand rule. So we have 2 rules in your syllabus. There used to be third one, which has been taken off from your syllabus. That was electromagnetic induction, has been taken off. You no need to study about that. So we have actually 2 rules, guys. One is your right hand thumb rule, which is used to find the direction of magnetic field using the direction of current. Second is your Fleming left hand rule. What is the left hand rule says? The left hand rule gives you the direction of force. What kind of force it is? Let's say if there is a current carrying conductor is kept in a magnetic field, it experiences a force. That force direction is given by Fleming's left hand rule. And as you can see in this diagram, this is your left hand. Do not, okay, I was in a class, there was a funny story I tell you. I was in a class and I was talking to my students over there, and there was an offline session, sometime we take. So I was talking to my students over there, and what they do, they found it wrong. The reason was, though they were using this thumb correctly, field correctly, current direction correctly, everything was fine, but the problem was they were using their right hand. They forgot. It just slipped from their mind that it is a left hand rule, it's not the right hand rule. So please guys, since they have made the mistake, you can also make the mistake, because you see, once you are sitting in examination hall, na, it happens like you are in tremendous amount of pressure, because it's a board exam, right? You have a lot of pressure, time problem also, because exam sometimes comes lengthy and all. So what do you do in that? Over there, you tend to make these silly mistakes. This is a silly mistake. You tend to make these silly mistakes. And once you come out, you say, oh shit, what happened? What did I do? Please don't let it happen with yourself. Please understand what exactly it is going on. So this is a left hand rule. This is not the right hand rule. In left hand rule, your thumb gives you the force, index finger gives you the field, and middle finger gives you current. To remember this, you can remember it, I think online, everywhere, in your classes, everywhere you has been taught there are two ways of remembering it: father, mother and child. And second way is FBI, whichever you like to choose, you can choose. What is father, mother and child? So I've said father, mother and child. So your thumb gives you, this is your father, F is force, F is father, M is mother, M is magnetic field, and C is current over here. So you can remember father, mother, child, or you can remember FBI. Either way, both the ways are correct, but most important thing is, in this particular part, is all three are perpendicular to each other. It means force is perpendicular to magnetic field. Guys, this question was also asked in past few years, board exams, that what is the direction of force? Is force perpendicular to current? Is force perpendicular to field? All three of them are perpendicular to each other. You see, if I'm putting a finger, I hope you can see all, right? In 3 dimension, if you can make out, you see all three fingers makes 90 degree with each other. All three fingers are perpendicular to each other. I hope it's visible to you, all of you, right? So please do not make this mistake. All right, now what kind of other questions are asked? Other questions are, what if the current and field are in same direction? In that case, will there be any force? No, absolutely, there will not be any force. Okay, so if you have current and field, it means, let's say this is a magnetic field and this is also the direction of current in a conductor. This is magnetic field, this is current. If they are parallel to each other, if they are in the same direction or opposite to each other, in that case the force will not be there. The force is there only in one case, when current is at either perpendicular or at some angle to the field, then you will experience a force. All right, I hope it is absolutely clear to everybody. Second type of problem which is asked is motion of a particle, motion of charged particle in magnetic field. This question has been asked also in past few years. All right, and what is this question is all about? Okay, how many particles we have? Let me go on a blank slide first, then we'll go to domestic circuit. So we have like electron, okay, then we have proton, then we have neutron, then we have alpha particle. And in fact, in 2018, this question was asked, alpha particle. Okay, so what happens when each type of particle moves in magnetic field? What will be the direction of force over there? Okay, so Fleming left hand rule is used in two ways, guys. When there is a conductor, when there is a current in a magnetic field, it experiences force, number one. Second is when any charged particle moves in a magnetic field, it also experiences a force. That is what we are going to study over here. All right. So what are the particles we have in our syllabus? Electron, proton, neutron and alpha particle, right? Yeah, right. Alpha particle is also there. So electron is negatively charged. I think everybody knows that, right? No question over here. There is no doubt, absolutely. All right. Proton is positive charge. Neutron, zero charge, no charge. Okay, or we can write no charge. And alpha particle is positive charge again. Okay, so if there is a magnetic field, let me change the color of the pen. All right, let's say if there is a magnetic field in this direction, charged particle has to be either perpendicular or at some angle with this magnetic field. If charge is moving in the direction of magnetic field, let's say there is any of these charged particle, if it is moving in the direction of magnetic field, the force will be zero. Please take your notebook, pen, paper, note it down. All right, note this thing down. This is important. All right. So electron negative charge, proton positive, alpha particle positive, neutron zero. So when neutron has no charge, so no matter how it moves, force will be zero in this. Will always be zero. Why? Because there is no charge. Okay. So neutron, however it moves, it will always be zero. Proton, when proton and alpha particle both are positive, as you can see, they both will follow Fleming left hand rule. What is it? Let's see our next slide. So let's say we have magnetic field in this direction. Let's say we have proton. Proton is moving in proton or alpha particle, both of them positive charge. So any positive charge, when it is moving in this direction, then how are we going to find the direction of force? Fleming left hand rule. All right. Okay, so what will be the direction of force over here, guys? What will be the direction of force? Let's see, shall we? Okay, so let's say you have your magnetic field. Force is given by thumb. Magnetic field, index finger. Current or charged particle motion. All right, so magnetic field is in this direction. Magnetic field, you see this finger which is moving. Magnetic field is in this direction. Motion of charged particle is in this direction. The force is inside. As you can see, the force is inside. So this is how it is calculated. So in this case, the force is inside. In positive charge, the force is inside. The only electron, which is a specific case, only the electron which goes opposite to the Fleming's left hand rule. Okay. Electron goes opposite to the Fleming's left hand rule. So for electron, this force will be coming outward. So when there is a positive charge, force will be inward. Okay, I hope it's absolutely clear to everybody. If there is negative charge, force will be outward. Inward means is going from outside, is going inside. Just take your thumb and you can realize what I'm talking about. See, this chapter is all about direction, guys. You understand finger rule, left hand rule, thumb rule, that is right hand rule. If you understand these two, your chapter is over. There's not much. But these things you must remember, guys, because in exam, the most favorite topic of the examiner in past 5 to 6 years has been first, solenoid. Second, right hand rule. Third, left hand rule. Fourth, domestic circuits. Over there, we will just discuss, what kind of question are also asked there. So please, let's finish this off, because electron will experience the force ulta, opposite. It means in case of electron, if Fleming left hand rule is saying inside, in case of electron, it will be opposite, which will be coming out. Please do not make this mistake. This question was actually asked. that if alpha particle is going towards north, if alpha particle is experiencing force in the north direction, where will be the force on electron? Opposite, in the south direction. This was the CBSE problem, past year problem. Okay, so let's go guys, let's go ahead. I hope I'm able to add some value in your knowledge. If that is true, please like the video, keep on commenting, come on, and keep on asking me the question. I'm going slow in this topic because it's a very small topic, but the understanding of this topic is very important, because you have a lot of rules involved, the directions involved. There's a three-dimensional way of things involved. All right guys, so it is all for you. Going slow, we'll do some problems also, past year problems. Anyways, I'm telling you where the problems are coming, what type of problems have come in exam. So all these are the part of past year problem, plus on top I'm just giving you the recap of everything. If you want a detailed understanding of the topic, you please watch my previous video. Over there I have explained a detailed view of this topic, where we have discussed everything. In fact, if you have not studied this chapter before, you just see that video. It will take about 1 hour, or maybe you can just go at 1.25 speed, maybe less than 1 hour, maybe 50 minutes or so it will take, and you will be good in that topic. Very important, weightage wise, 5 to 8 marks was asked last year, and you can expect 5 to 8 marks this year also. But trust me guys, whatever I'm doing over there, whatever I'm teaching, these two classes, these two lectures of mine, you will not have question outside this lecture. So whatever we are doing, maybe words may be different. They may ask you here and there, small words, small here and there, just a words play. But meaning of that will be same. So please understand this, what we are doing. If you understood, is good. You can always rewatch this video later on. Keep on putting the good comments, bad comments, whatever you have. Tell me how we can improve. Tell me what you want. If you want me to include anything more. If any doubt, please let me know. I will reply that on the comment box. This is how it should go. I hope all of you will do well in your board exam. For that, we are posting regular videos. We are doing really hard work. So your appreciation would really count for us. Let's go for next part. Okay, so the next part over there is your domestic circuit. So what is this domestic circuit? Important topic guys. Since electromagnetic induction has been removed, it means AC generator, AC motor, EMI, right hand thumb rule, everything has removed. Right hand that finger rule, this one, okay, for EMI. This right hand thumb is there, by the way, for that. Okay, so we are talking about the electromagnetic induction. That topic has been removed. So now examiner is only left with very few topics. He cannot go anywhere else. So he has to come down to domestic circuit. So please understand this domestic circuit. There are very important topics in domestic circuits. This is schematic diagram taken from your NCERT book. Okay, so this is how it works. There is a live wire. It means electricity is coming from the station through that. This is a live wire. In live wire, you see there is fuse which is given by electricity board. So fuse is always on the live wire guys. Again, this question was asked as an MCQ, that where is the fuse put? Neutral wire, live wire, this wire, that. Obviously it's a live wire. I think the answer is pretty clear in this from this particular diagram. They can even ask you this diagram. Second is, it passes through a meter, it passes through a distribution box, main switch and all, and it goes over there. What the thing you need to notice, in India we have 220 volt, 50 hertz. 50 hertz is the frequency of AC. 220 voltage is what is given from the power station to our home. I hope it is absolutely clear. So 220 volt, 50 hertz. Sometime examiner, some crazy guys out there, no offense to any examiner, but they like to make your life difficult. They will say, okay, in your home, in AC circuits, current changes direction every 1/50th of in 1/50th seconds. The answer is right. The meaning of frequency is that in 50 times in 1 second, it changes the direction. Okay, this is the meaning of it. So the question has been asked. This is the reason I have discussed this thing with you. 220 volt, 50 hertz. This is the supply we have in our homes. Now, as we go further, you can see the live wire is there. Now, there is one neutral wire. What is the purpose of neutral wire? When the electricity goes in, it has to come out also. It has to complete the circuit. So neutral wire is used for that. Third we have is your earth wire. What is the purpose of earth wire? The earth wire is basically a wire which takes extra charge. Let's say you have your refrigerator. Let's say we have a refrigerator. The current is coming, and because some leakage, some static leakage, some current leakage, something is there, because of that you have current, the charge over deposits on the surface of this refrigerator. How do you feel that? You go to a refrigerator, sometimes you just touch it, you will feel, oh my god, this current. I hope everybody has faced it everywhere, right? The reason for that is because this is not earth. So it has to be earth. How it is earth? So we take a small metal piece, put it over here, and take a wire and put it in earth. What does earth do? Earth has zero potential. So what does earth do? It takes all the charge, extra charge from this, and all the charge goes to earth, and we make this charge free. So earthing is very important. It's a safety kind of thing which is very important in our circuit. So these three things are there. You need to understand this. You need to plot this. One more thing, guys, one more thing. All the things, all the appliances are in parallel over here. Okay, in parallel. Okay, so this thing is also important. Once you plot the diagram, this is your domestic circuit. I hope it is absolutely clear. All right. All right. So what topic? Okay, we have one question from Bookhead. Okay. All right, it says that what topics have been deleted from this chapter. See, electromagnetic induction, electric motor, AC generator, these topics have been taken off. AC, DC differences and all has been taken off. So whatever we have, I don't know your real name, okay, but thing is, in my last chapter and this chapter, and last lecture and this lecture, you can just have a look over there. Entire syllabus with detailed explanation is mentioned in my previous lecture, and this one is a recap of what we have done in our last lecture. Okay, so you can have a look over there. Still you have a doubt, please leave your comment in comment box so that we can get back to you. All right, so let's go further. Let's go further. Okay, so what other things are there? One more thing which comes here. There are two kinds of supplies. Okay, one more type of question which is asked in exam is we have 5 ampere and we have 15 ampere, guys. These two things are there, 5 ampere and 15 ampere. Okay, so what is this meaning of 5 ampere? 5 ampere line is used for small appliances, small appliances. Whenever there is a heavy appliances like electric motor, air condition, heavy appliances, whenever we have, for that we use 15 ampere. For light appliances like you have nowadays your TV, mobile phone charging, fan, light, all these things, there we use 5 ampere. Okay, so this question was also asked as a part of MCQ. 15 ampere line was used where 4 answer choices were there. There you had to just click which one was the electric motor, the heaviest one. Not much. All right. Okay, thank you, Bookhead. Right, please write your real name so that I can address you. All right. Okay, so let's go with the next part. All right, so this was your domestic circuit. Couple of things which are there, guys, which are equally important. One of them is overloading. Overloading, this is a very important topic, guys. Overloading. Second topic to overloading is short circuit, and third topic is fuse. So these three topics we will just see, and after that we will begin our questions. All right, though I have not taken any direct question, but if you see my video again and again, I have covered so many past year questions which was asked. Because over here in this chapter, guys, mostly the questions are direction based. Use your right hand thumb rule, make a direction, left Fleming left hand rule, find out the direction. So first is that. Second type of question which comes is domestic circuit, overloading, fuse. These subjective ones, they are not there, there's no numerical side sort of thing, so don't worry about it. You are covering everything. Just watch my video once, twice, thrice, and you are prepared for the board exam. You can mark my words. All right, so let's go. Let's understand what is this overloading. Let's say, guys, you have a socket in your home. Let's say you have a socket in your home which gives you a supply of 5 ampere, small one, and you take one extension. 1 socket, 2 socket, 3 socket, 4 socket, 5 sockets. You take your extensions and you put this extension to this. I hope everybody understand what I'm talking about. You take extension because in one socket you can only put one charger. You have 5 sockets, now you can put 5 chargers here, right? So what happens is once you put 5 chargers over here, when the 5 charges come over here, the demand of electricity increases. The demand of electricity increases, and because of that, all the appliances which are there, which are demanding high electricity, high current, so there is a high current comes from flows inside. And as we know, the more the current, the more heat will be there, the heating effect of current, right? I square RT. That's the formula of that. So using that formula, the heat will be, it depends upon square of current. So the more the current, the more the heat, and because of that heat, we have fire. Lot of cases like this, lot of casualties happen, lot of different kind of problem happens, and it happens because of extra demand created by the appliances. You put extra, or maybe some faulty appliance can also do the same thing. But I hope you understand what is the meaning of overloading. So this entire process is overloading. So what happens is you have a higher demand of current. All right, how to prevent it? Very easy. So what do is we put fuse in it. We put fuse wire on this live wire. Remember, fuse is always on the live wire. Okay, we put a fuse over here. So what does fuse do? Understand the fuse also. What does fuse do? Fuse has a wire inside. The melting point of this wire, melting means it will just melt away. The melting point of this wire is way less than the actual wire. This is a copper wire in our household. The melting point is way less than that. And what happens is when the current passes, higher current comes, it passes through this fuse wire get melt because of high current, high heat, and the connection breaks. The current cannot go further, and we save our home. We save our home. There is no fire. This is how the overloading is protected. Overloading, this question is very important, guys. What is overloading? So you should be able to explain it in your words. If you want, you can even plot this diagram. It's not wrong, by the way, okay? You can even plot this diagram, understand it, and how it is protected using a fuse. This has to be your answer. Very important. Again, I'm telling you, very important. Another very important topic with this is, second is your short circuit. Okay, yeah, all right. So short circuit, next one is short circuit. So let's take the short circuit also. How does short circuit happens? Let me show you. So short circuit, guys, short circuit. Now what is this short circuit? So let's say, okay, here we are plotting straight lines, straight wires and all, but in reality the wires are not. If you open any electrical circuit and all, you will see all the wires are entangled with each other, right? So because of the entangling, what happens is over the period of time, the wire, if it is not very good quality, it loses the coating on top of it, which is an insulated coating on top of it. The coating goes away. So because of that, what happens is, let's say this is my wire which is going in some appliances. Let's say this is a bulb, okay, and these wires are touching with each other. And if the coating goes away, current comes over here, it goes over here. Instead of going in this system, the current just passes through this, because current likes the lowest resistance path. So because the current is very low, the resistance is very low, these two wires met, came in contact, current passes through this, the resistance is very low over here. We know that formula of current is I is equal to V by R. If R is low, what will happen to current? Current will be very high. The low the R is, the high the current is, as you can see from this Ohm's law. I hope everybody remembers that. If you have not seen this, again, if you are weak in this, I have recorded, went live, explained electricity in depth in my first video. Please go over there on our channel, search for that and watch it, and you will surely like it. I have explained everything over there in depth, everything over there in depth. Okay, so please go and watch that. Everything will be clear. Then you can come back here and understand this particular path. Okay, so this is a short circuit. So short circuit, how to prevent a short circuit? No, because of this, when high current flows, what happens? The heating effect of current, the wire gets really heated, the lot of heat comes into play and it catches fire, and we have a fire everywhere. That's what happened in short circuit. And how it is prevented? It is also prevented using fuse. So what do? We put a fuse over here. Okay, 1 second guys. All right, oh, shifted here. So we put a fuse over here again in the wire. So it does the same purpose. As soon as there is a high demand of current over there, because of this low resistance, the fuse wire melts, the connection breaks, and no more current in the circuit, and we save our harm. This is how it works. I hope it is absolutely clear to everybody, right? Absolutely clear. Come on, tell me in the comment box if you like it. Let me know in the comment box if you're enjoying this video, if you're able to understand this. I'm going quite slow in this because this chapter again is a smaller chapter, but there's a lot to understand in this chapter. All right. So this was the recap I wanted to give you. Now we'll shortly go for some questions, MCQs and some questions, and how does it work. Magnetic lines of forces is one of them. Let's see how it goes. Okay, so we go for further questions. Okay, multiple choice questions. So this is what everybody knows. Okay, so first question is, which of the following statement is not true? Over here. Guys, see, this is where examiner catches you. He writes not true, incorrect. And what do? Because when we are giving the exam, we are too much in stress, too much of pressure is there. We just go through with the question and we just write, oh, I know this is the right answer. No, read the question carefully. This is where you make mistake. So let's go. Which of the following statement is not true? In a house circuit, lamps are used in parallel. Yes, we have seen in domestic circuit, it's in use in parallel. So this is a correct statement, right? Okay. B, switches, fuses and circuit breakers should be placed in a neutral wire. Is it correct? Come on, answer me in the comment box. We just discussed a few minutes back. We just discussed that. Switches, fuses and circuit breakers should be placed in neutral wire. Is it true? Fuses must always be in live wire. So this statement B over here is clearly not correct, and we were supposed to find the not correct, hence B is the right answer to this question. All right, yes, I can see everybody is writing B. Yes, absolutely. Thanks a lot guys, thanks a lot for all those comments. Yes, thanks a lot, and keep on motivating us with your kind comments. We can continuously make more and more lectures for you, in-depth lectures, and if you want any special class or something, any lecture possible, any topic, please leave it in the comment box and we will make that class for you. All right, that lecture for you. Come on, next one. So this is the B answer, so we can just stop over here, right? We no need to go further. Next part. All right, the next one is in the last year board examination. Okay, so guys, okay, this might look little bit of lengthy in reading, but you should be aware that this kind of question may be asked in the exam too. All right, so I've just taken one example sort. we are free to do experiments over here, right? So in the last year board examination, Rahul were asked a question where he had to choose a statement which was correct. Will you be able to answer that? So a magnet exerts a mechanical force on a current carrying wire, and if the wire is free to move, this force can produce a motion in the wire. Is it correct? Think about it. A magnet exerts a mechanical force on a current carrying wire. Yes, it does. Fleming left hand rule, we know that, right? And if the wire is free to move, its force can produce a motion. Yes, and if wire is free to move, the wire will move. Yes, absolutely correct. So this is a right answer. Absolutely correct. Second one, let's check, because we have one answer is all of these also, remember? Okay, so we need to check that also. The other one, when current carrying conductor is placed in a magnetic field, the mechanical force is exerted on the conductor which can make a conductor move. Yeah, this is just the first one. Same thing. It is also a correct answer. If two are correct, we don't need to check the third one because there can only be one answer correct. And all of these options gives us the flexibility of selecting everything. So the right answer to this question is all of the above. But third one, direction of force acting on a current carrying wire places the magnetic field perpendicular to the direction of current. We have discussed that. All three are perpendicular. Left hand rule. Yes. All three are perpendicular. Right? Alright. So a right answer is D. I can see in comment box everybody is writing D. Thank you very much. Let's go and do the next question. Next question is on your screen. Recently, in a science class test, you are asked a question where you have to say whether the statements are correct or not. The minimum force is exerted on a current carrying conductor only when it is perpendicular to the direction of magnetic field. Is it right or not? Question. Come on, give me, answer me in comment box, everybody. The direction of force on a current carrying conductor placed in a magnetic field can also be reversed by reversing the direction of magnetic field. Yes. Yeah. No force acts on a current carrying conductor when it is parallel to the magnetic field. We discussed that also. If conductor is parallel to magnetic field or opposite to magnetic field, no current. Only way the force is when this is my magnetic field, this is my direction of current, it has to be either perpendicular or at some angle. The moment it becomes parallel, no force. Alright. So answer over here is again is all of the above. Yes, I can see in comment box everybody has given that. Very good. Thank you very much. So let's go the next part. Next question. The most important safety method used for protecting home appliances from short circuiting or overloading is, I hope everybody knows this answer. Come on, in comment box I need the answer. I have explained this thing in depth, in detail. Come on, give me an answer for this, everybody. Yeah. So the answer over here is yes, absolutely true, absolutely correct. I can see in the comment box. Yes. So your answer is, come on. Yes, I can see comment box. Everybody is writing use of fuse, which is absolutely correct. This is CBSE problem, guys. This is CBSE PYQ. Past year problem, past year question, board question. Okay. Now let's do the next one. Okay. All right. Next question is choose the incorrect statement. Okay. Choose the incorrect statement. So which one is incorrect statement? Right hand thumb rule is used to find the direction of magnetic force due to current carrying conductor. Is it true? Right hand thumb rule. What does right hand thumb rule gives us? Right hand thumb rule gives us magnetic field. It talks about is used to find the direction of magnetic force. Is it right? Is it correct? Please give me an answer for this. Is it in front of you? Please give me an answer. Read the question carefully, everybody. Please give me an answer. It says, A answer says, right hand thumb rule used to find the direction of magnetic force due to the current carrying conductor. Okay. So, this statement, okay, in India the AC changes direction after every 150 seconds, this is true, this is absolutely right. Remember when I was explaining about it, 220 volt 50 hertz, I used a statement over there in which every AC changes its direction 50 times in 1 second. This is the same statement actually. So the answer over here is we need to find incorrect statement. This is correct. This is the correct statement. So this is true, right? We need to find incorrect. So right answer is A of this topic. Okay, because it gives us, if you can read that, it's asking about right hand thumb rule gives us magnetic force. No, it gives us magnetic field. So that's the incorrect statement. Now next one. Let's see the next one. Okay, which of the following statement is correct, incorrect regarding magnetic field lines? Okay, this is also a very important topic, magnetic field lines. Well, I have not discussed today much about magnetic field lines. Those you want to understand that, you can watch my first lecture. There I've explained in depth. All right. So let's go with this magnetic field of line. So it says the direction, so we need to find incorrect, okay? Again, incorrect, not the correct ones. The direction of magnetic field at a point is taken to be the direction in which north pole of a magnetic compass needle points. Is it true? Is this statement true? Come on. Yes, it is correct, but we need to find incorrect. So this is not the right answer. Second, magnetic field lines are closed curves. It is also right, also correct, but we need to find incorrect. So B is also not the answer. C, if magnetic field lines are parallel and equidistant, they represent zero field strength. It does not represent zero field strength. So if magnetic field lines are parallel and equidistant, they do not represent zero field strength. So this is an incorrect statement, which is the right answer for this question. You see guys, I have taken lot of incorrect, not, these kind of words in this particular class. The reason being, this is the kind of practice you need. CBSE examiner, he likes to use such kind of words which disorients you. In hurry, you go over there and you correct the answer because this is the right answer. This is the correct statement. Without reading this, you just click it and go forward. No. Please read the question carefully over there. All right? Please read the question carefully. Let's go to the next point. Next question coming on your screen. So it says, which of the following correctly describes the magnetic field near a long straight wire? So when we are talking about long straight wire, answer choices are: the field consists of a straight lines perpendicular to the wire. Is it true? We know that using our right hand thumb rule, magnetic field of lines will be, in this case, if you remember, because this will be in this direction, right? Concentric circles. So which is the right answer? Who's going to tell me in comment box? Come on. Answer me in comment box, guys, please, everybody. Okay. The field consists of concentric circles centered on wire. Is it the right answer? Yes? Yes, it is the right answer. In comment box, I can see everybody is giving the right answer. Very good, guys. Keep it up. Let's go to the next question. All right. This is also a PYQ. Okay. Previous year problem. Let's go and take this question. Okay. Which of the following statement is or are correct? Okay. All right. So space surrounding a magnet in which magnetic force is exerted is called a magnetic field. It is correct. Yeah. What is a magnetic field? Magnetic field, this is a definition of magnetic field, guys. What is a magnetic field? The space surrounding a magnet in which magnetic force is exerted. That is a magnetic field. Second, so this is a correct statement. Okay. We need to find correct only. All right. So let's see the second one because we have an option of all of the above also. Okay. So it says, second one says the direction of magnetic field at a point is the direction of the resultant force acting on a hypothetical north pole placed at that point. If you think, read this particular statement carefully, you will realize that this is the right answer. Okay. Third one, because it may look like, okay, what is it? So we can also read the third one. The magnetic field lines always begin from north pole and end in the south pole. This is a simple straight. We have been reading this. So this is also correct answer. So two correct answer. Third one, we may think, okay, this I can tell you this, but once you're sitting in exam in a pressure situation over there, you make mistake in this kind of statement. But we know that we have answer of all of the above. There is only one answer choice correct. So answer is D. I can see in comment box everybody has written D. Very good, guys. Keep it up. Keep it up. Your preparations are going great. I'm expecting a lot from you guys. Okay. So keep on putting a comment if you have any doubt and keep on preparing well. Let's go further. Okay. So we have, okay. Next question. Neeru. Good name, right? Nice name. So Neeru is completed her science chapter where she wrote some statements. She wants to know whether the statements are correct or not. So Neeru wants help from you. Okay, this is a question actually. So what is this? A concealed current carrying conductor can be located due to magnetic effect of current using a plotting compass. Come on, give me an answer for this. Everybody, okay. Statements. I have deliberately taken this difficult problem for you guys, okay, so that you can have a practice. You know, easy. Life is not that easy, guys. You may have this kind of difficult problem also. You need to sit down over there, put your head, think about it, read the question. Okay. Now, over there, second is the magnetic field lines around the straight conductor or straight wire carrying current are concentric circle whose centers lies on the wire. The magnitude of magnetic field produced by a straight current carrying wire at a given point is inversely proportional to the distance of that point from the wire. And fourth one is, when electric current flows vertically downward, then the direction of magnetic field is anti-clockwise. Which is it? Okay, so here please give me in comment box your answer in comment box over there. Please answer in comment box, everybody. Okay, so I can give you the right answer over here. Come on, discuss in the comment box why is this correct, and I'll reply to you on this in the comment box. All right, guys, let's go for some assertion reasoning questions. Okay, come on, discuss in the comment box your reasons over there. Do some hard work here, guys. Come on, everybody. Assertion reasoning question. Let's do some question of that also. Okay, this is also an important part of it. So it is unsafe to touch live electric wires as the person gets severe shock, and in many cases it can be fatal, leading to death. The electric current passes through the body to the earth, forming a circuit and burns the blood. Is assertion correct? It is absolutely. So you are not supposed to touch the live electric wires. Why? Because it completes the circuit and you may even die. So this is true. Correct? This is absolutely true. What about the second one? Reason. The reason to this is electric current passes through the body to the forming a circuit is absolutely true also. And is reason able to explain the assertion? Yes, it does in this case. Have a look. So the answer over here is both the assertion and the reason are correct. Reason is correct explanation of the assertion. I can see in the comment box people are writing A, which is absolutely right answer. Okay, very good, guys, keep it up. Okay, next one. Let's do the next problem. What does it say? Long distance transmission is done through AC load. Yes, we do that. Long distances through AC load. AC loads have lesser loss of energy. Is it true? This is also true. So this is true, this is also true, and this reason is able to explain the assertion. So the right answer over here is, I can see in the comment box people writing A, and A is the right answer. Absolutely correct. Absolutely correct. So guys, your preparations are going well. Those who are late, those who could not see my lectures, those who are still not able to understand few things, watch my first lecture on magnetic field. This is the second lecture. Both together, these two together will make your base. You will be able to solve problem in the exam. All right. Those who are weak in electricity, please watch my electricity chapters over there. Those lectures on electricity, I have covered that extensively. All right, and on human eye also. All right, so this is it. All right, okay, so we are running short of time, guys. With this, I have to leave. Well, we have covered quite a lot of questions in our class. I'd like to cover some more. Anyways, see you again shortly. And I hope please drop the comment, like the video, and we'll be looking forward for your response on this. Take care, guys. Okay. Bye bye. Thank you very much for your response. Thank you very much for your participation. Bye bye.